Question 1. DS. If S is the sum of 9 terms A of n, where A of n are integers, for n equals 1, 2, and so on till 9, is at least one odd number contained in the sequence A of n. Condition 1. S is an odd number. Condition 2. A of n are positive for all integers n from 1 to 9 inclusive. Solution. Now we will solve this DS question using the variable approach. Relationship between the variable approach method and common mistake types 3 and 4 A or B. The most difficult questions are key questions, which relate to integers, statistics, probability, inequality, and absolute value. Answering these questions correctly and efficiently is key to attaining a score of 50 to 51. These questions are usually related to CMT 3 and CMT 4 A or B, so you should double-check the question with these CMTs after applying the variable approach. Also, these high-difficulty questions are typically seen after the 17th question of the 31 questions, so be very cautious on key questions, especially integer and statistics questions in the last few questions. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find out whether there is at least one odd number contained in the sequence A of n if S is the sum of 9 terms of A of n, where A of n are integers, for n equals 1, 2, and so on till 9. We have learned that odd plus odd, or even plus even, is even, while odd plus even is odd. You should understand how to solve this question, as I will explain below. You should also be capable of deciding whether to use CMT 1 or CMT 2. Also, this is an integer question, and therefore, we will have to apply CMT 3 or CMT 4 A or B. Follow the second and third steps. From the original condition, we have 9 variables. To match the number of variables with the number of equations, we need 9 equations. Since conditions 1 and 2 will provide 1 equation each, E would most likely be the answer. Recall 3 principles. Choose E as the most likely answer. Let's take a look at both conditions together. We get the sum of 9 positive integers to be odd. If all the 9 integers are even, the sum will be even. Since the sum is odd, at least one integer is surely odd. So, the answer is unique, yes, and the conditions combined are sufficient by CMT 1. Which means that the answer must be in terms of a unique yes or no. Thus, C seems to be the answer. However, this is an integer question, and an easy C as an answer requires us to look for CMT 4A. We have to look at the relationship between VA and CMT 4A before finalizing our answer. So, we will have to consider each condition separately. That's right. You should remember how to solve the question like this. This type of question does not appear that often in the actual exam. There are about 4 of these questions per exam, after the 17th question. Let's take a look at each condition separately. Condition 1 tells us that S is odd. Now, S is the sum of 9 integers. And for S to be odd, an odd number of integers should be odd. So 1, 3, 5, 7, or 9. So at least one integer is odd. The answer is unique, so the condition is sufficient by CMT 1, which means that the answer must be in terms of a unique yes or no. Condition 2 tells us that A of n are positive, for all integers n from 1 to 9 inclusive. This just tells us that all 9 integers are positive. We cannot say anything about the types of integers. All can be even, that is 2, 4, 6. Then we get no. but all can be odd too. 1, 3, 5, and so on. Then we get yes. The answer is not unique, so the condition is not sufficient by CMT 1, which means that you get both yes and no as the answer. It is not sufficient. If the question has both C and A as its answer, then A is the answer rather than C by the definition of DS questions. This is an approximately 50 to 51 level question. Be sure to do a lot of practice, and you will ace these questions when you write the actual exam. Condition 1 alone is sufficient. So, A is the correct answer. Answer: A.